Good evening, everyone. Today I'll be teaching chemistry. First, let me introduce myself. My name is Zoey Ang, and you can call me Teacher Joey for today. First, I will do a basic recap. What is chemistry? Chemistry is the branch of science that deals with the properties, composition, and structure of elements and compounds, how they can change, and the energy that's released or absorbed when they change. So basically, chemistry is the study of all matter. And today's topic is about chemical reaction. Chemical reaction is a reaction that happens when two or more substances react to turn a new substance. The general formula for chemical reaction is A plus B yields AB, and the symbol A and the symbol B is the reactant, and AB is the product. Now we'll move on to the examples of chemical reaction in our daily life. And first is burning wood, storing milk, mixing acid and base, digesting food, cooking an egg, heating sugar to form caramel, baking a cake, roasting of iron. If you can see it properly, these examples actually happen every day, like few times a day. And while you didn't know about it, it's actually a sample of chemical reaction. And this chemical reaction follows with some changes. Some may change in volume, some may change in their state, some may change in their colors. And what's visible in the eyes is basically the colors and the state and the volume. And after I give you this example, I hope that you have the general idea about chemical reaction lah. Let's move on to the chemical reaction symbols, like the symbols used in a chemical reaction. The first symbol used is the plus sign. It's used to separate two reactants or two products. So it's not like how it's in the example A plus B. It separates the two reactants A and B. And the arrow symbol yields is used to separate reactants from products. So it separates A, B with AB. And the double arrow has the same function as the one arrow function, but it's used for reversible reaction. And what is reversible reaction? Reversible reaction is like a reaction where the reactants and the product where a reaction where the reactants turn into a product and product turn into the reactant simultaneously. So they at the same time they changes from A to B, B to A kind of thingy. And the letter S, L, G, A, Q is normally placed after the substance, like aluminium for example. So they will be written as A, L, S in a bracket. And these letters respectively is used to represent the solid state, liquid state, gaseous state, and aqueous solution state. Now we'll move on to the last two, is the arrow with the triangle or heat word above. It indicates that heat is used to supply to the reaction. One of these chemical reaction that actually can use this is from when you turn water from its liquid state into the gas state. It needs to be heated so that it can change its state. Now is the arrow with the word alike above. It indicates that the reaction is undergoing electrolysis. This is an example of reversible reaction. Dinitrogen tetroxide yields 2 moles of nitrogen dioxide, and 2 moles of nitrogen dioxide yields dinitrogen tetroxide. So like they turn A into B, B into A. So they turn simultaneously. That's why there's like the double arrow. Not all equations have this only some, so I hope you don't use this for every chemical reaction, yeah. And now I'm going to discuss the law of conservation of mass. In the law of conservation of mass, it states that in every chemical reaction, the mass of the reactants and the mass of the products must conserve. So if your mass, the mass of your reactant and the mass of your product is not the same, it means there's some mistakes in the chemical reaction, and or you must balance it. It's not balanced yet. And so that's it for the law of conservation of mass. But later I will teach you how to balance the equation if it's not balanced yet, and I'll give you a sample whether the law of conservation of mass is true. Let's move on to what's conserved and not conserved in a chemical reaction. What's conserved is normally the mass type of atom, number of each atom. So if this is not conserved in your chemical reaction, you should double check. But what's not conserved is normally the color, physical state. You can turn from solid to liquid, liquid to gas, gases to solid, and it will changes. And the third one is the volume is not conserved. Like you can turn like a big volume of matter into a small volume of matter because of with the help of chemical reaction. And the last thing that's not conserved is the number of moles of reactants or products. And as an example, whether or not as a sample of chemical reaction is methane when reacts with oxygen yields carbon dioxide and water. This actually has the same number of each atom. Like they have 4 oxygen atoms, 4 hydrogen atoms, and 1 carbon atoms. So they conserve it. So kind of correct lah. Yeah, it's correct. Let's continue. I'm going to tell you the factors that affects the chemical reaction, like the speed of chemical reaction, the reactant concentration, because if your reactant concentration decrease, like how packed it is, it can change the speed and the surface area between the reactants, like in particular the solid state in heterogeneous systems, and the pressure. And the fourth one is the activation energy, the amount of energy required to make the reaction start and carry on spontaneously. Fifth is the temperature. When you rise the temperature, the speed of the reaction will increase, and if you lower down the temperature, the speed of the reaction will decrease. Like how when you boil water, if you heat it up really into 100 degrees, it will boil faster. Like if you turn the heat into high heat, it will boil faster. But if you turn the heat into low heat, it will boil slower. And the sixth one is the absence of catalyst. Catalyst is like a substance that changes the pathway or mechanism of a reaction, which in turn increase the speed of a reaction by lowering the activation energy needed for the reaction to take place. And the seventh is it only happens for some reaction. For example, for some reactions, and the presence of electromagnetic radiation, most notably ultraviolet light, it only affects some. Okay, so don't apply it to every chemical reaction. Now an example of chemical reaction. Aluminium when reacts with oxygen gas yields aluminium oxide. It's not yet balanced. As you can see on the right side, there is 2 aluminium atoms and 3 oxygen atoms, and on the left side there is one aluminium atoms and 2 oxygen atom. To balance it, first you need to add coefficient in front of every substance. So one aluminium plus A oxygen gas yields B aluminium oxide. So you can write it as 1. You can write it on the left side, there is 1 aluminium and 2A oxygen. On the right side, you can write 2B aluminium atoms and 3B oxygen atoms. To balance it, first you must find the value of B. As you can see, 1 is equal to 2B. Okay, it must be balanced. So 1 is equal to 2B, 2A is equal to 3B. If 1 is equal to 2B, we can find the B is equal to 1 over 2. And if the 2A is equal to 3B, so if we have just found B is half, so 2A is equal to 3 times half, so it's 3 over 2. So A is equal to 3 over 4. And the coefficient in front of aluminium is still 1, but we need to balance it because there's no fraction coefficient in front of a substance. It cannot happen. So we must balance it we must balance it by multiplying. Okay, as you can see, right, so that it can be balanced, we must time it with the number 4. So B times 4 turns into B equal to 2. A times 4 is equal to 3, and 1 times 4 is equal to 4. So it will be written in a balanced form as 4 moles of aluminium when reacts with 3 moles of oxygen gas yields 2 moles of aluminium oxide. Let's continue. We need to prove whether the law of conservation of mass is there. Okay. First, we must find out the molar mass of aluminium. Aluminium is 27, oxygen is 16, and there is 4 aluminium atoms, so 4 times 27 plus 3 times 2 times 16 for the oxygen, and there is also the same on the right side, so is 204 is equal to 204. It's proof. Okay, so when it's not balanced, like for example, when it's not balanced, on the right side we have 1 aluminium atom, so 27 plus 2 times 16 is equal to 32, 27, so 59. And on the right side is 2 aluminium, 2 times 27 plus 3 times 16, so 48, 54 plus 2 and 102. So it's not balanced. That's why we need to balance it, because the mass is always the same on both sides. Let's continue. I'm going to teach you how to read it. First, for the but not balanced equation, we read it as aluminium when reacts with oxygen gas yields aluminium oxide. So the plus symbols is read as when reacts with oxygen, and don't forget to add the gas after the formula if it's written there, yields aluminium oxide. If there is in the balanced form, the coefficient will turn into 4 moles, like the coefficient moles of, so 4 moles of aluminium when reacts with 3 moles of oxygen gas yields 2 moles of aluminium oxide. I think it's quite easy. For another example, Laya, we read this equation as potassium powder when reacts with diluted calcium chloride yields diluted potassium chloride and calcium powder. So the S is normally turned into powder, and AQ is normally turned into diluted because it's a solution. Okay, please note this. As this direction is already balanced, like 1K at one K atom there, one K atom there, and one calcium atom there, one calcium atom there, chlorine atom, one chlorine atom, and one chlorine atom, like, so it's balanced. We don't need to turn it already. We don't need to balance it already. Now we continue to the types of chemical reaction. First is the general type, and we'll move on to the specific type in our next video. First is the direct combination, or commonly known as synthesis. Their general formula is normally written as A plus B yields AB. And second is the decomposition reaction or analysis. Is the opposite of direct combination. AB yields A plus B. And single replacement is normally the change of atoms from one position to another. But there's two types, okay? It's normally divided when A is a metal and A is a halogen. When the reactants is A and BC, when they add each other, if A is a metal, they will turn into AC plus B. And if the A is halogen, it will turn into BA plus C. Okay, so you must note it down. It's different. You cannot just replace it randomly, okay? You must know whether A is a halogen or A is a metal. And fourth is the double displacement metathesis. Double displacement is common formula is AB plus CD yields AD plus CB. Normally a zero charge substance or compound, they each have cation and anion, and this cation and ion will exchange their partners in this double displacement. That's it for general types of chemical reaction. And now let's continue. This is the general picture for the chemical formula. And the examples for synthesis, we have 3 moles of barium when reacts with dinitrogen yields barium nitride. And for analysis, we have 2 moles of ammonia when yields dinitrogen and 3 moles of hydrogen. For single replacement, we have zinc when reacts with hydrochloric acids yields zinc chloride and hydrogen. For metathesis, we have ammonia when reacts with barium hydroxide yields water and barium nitride. And now I'm going to explain about activity series of metal and halogen. The tables are divided into 2 for metal and non-metal. For metal, they are divided into 5 groups. The most reactive one until the least reactive one, from top to bottom. The first group is for lithium until sodium, and they can react with cold water, acids replacing hydrogen, and can react readily with oxygen forming oxide. And for the second group is from magnesium until cadmium. They can react readily with steam and acid replacing hydrogen, and react readily with oxygen forming oxide. And cobalt, from the third group is from cobalt to lead, and they react readily with acids but not water to replace hydrogen, and they react readily with oxygen forming oxide. And for the fourth group, there's hydrogen until copper. They react readily with oxygen forming oxide. And for the last group, mercury until gold, they are mostly non-reactive, so they decompose based on heating alone. I'm going to further divide this. To remember easily, almost all the groups can react readily with oxygen forming oxide except for the fifth group. And for the third group until the fifth group, they can decompose in the presence of heat and hydrogen. Now we're going to talk about the nonmetals. The nonmetals are divided. There's 4 nonmetals, and their reactivity is anion above can replace the anion below on the list. So the halogen on top can replace the bottom, but the bottom cannot replace the top. And for the metal with lower activity series also cannot replace the metal with higher activity series. For the reaction, for example, is supposed to be A plus BC yields AC plus B. But when A is less reactive than B, it will be written as NR, no reaction. So the example is aluminium and added with sodium nitrate is no reaction. As you can see on the list, natrium, sodium is on a higher place than aluminium, so the aluminium cannot replace sodium. Sodium is in the first group and aluminium is at the second group, so it's not feasible. Okay, that's it for today's lesson. I hope that this video will be reviewed and be listened properly. I hope that this will be useful. Thank you. That's it for today. Bye.